There you go. This part isn't the best. Basically what it's saying is looking at these images, right? Let's see if I zoom in a little closer. Determine which angles or segments are congruent. Describe the transformation. So it's horrible because basically, so here they say congruence, angles A and C are congruent, right? So they're saying this one and this one are congruent. The transformation is a translation. So they're saying if I slide A over, it'll match up with C. Now remember that when it comes to angles, I'm really only looking at this part right here. I'm not looking at the length of the sides. So even though the length of the sides, you know, C, we can definitely see that C is much shorter than A, but that doesn't matter. What matters is the size of the angle. Now, if you can kind of see, this is where it's a little bit weird. I'm going to switch colors. You can kind of see this is not the most exact mathematical way to do this, but they don't actually give me a mathematical way for me to figure this out. So if I look at this square, right, I have this big triangle here, and I have this big triangle here. We can agree those two triangles seem to be about the same size, right? Yeah, right, they leave them about the same amount with the square that's left over. This one, is that one look the same size as the other two? No, it's a little bit bigger, right? So if I erase it, erasing everything, whatever. If I erase it, you can see that this red line cuts directly in the middle of the square, okay? These, not so much. So you see what I'm saying, that they don't actually give you a mathematical way to do this. You kind of just have to look at it. And if you look at it quickly, you would be like, yeah, they're all the same. But when you actually take a closer look and you do what I'm going to call them the cheat way, right? Just kind of eyeballing it, you can see that B is not the same. It's a much smaller angle compared to the other two. Okay, so that's why angles A and C are congruent, but not B. There's nothing that'll match. If I slide B over on top of C, they're not going to be the same shape. Okay, they're not going to be the same size of the angle. The next one is angle AB and CD are congruent. So once again, it's kind of, we're going to call it the fake math because it's not really math. I'm just kind of looking at it and saying, okay, I think this might work. So I have, right, here's one, a little bit of another square, another bit, and another bit. So that's pretty much like what? 1, 2, 3, we'll say. About 3 squares I cut through. 1, that little bit, another 2, 3. Do we kind of see it? We kind of see how they're the same shape, how they're the same length. The proper way, and I like this one better than the angles, because with this one, what I can actually do is do the distance formula, right? I can make up my points, right? I'm going to say that this is 0, 0. So then 1, 2, 1, 2, 3, 4. This is going to be 2, 4. And this one is going to be 1, 2, 3, 4, 4, 1. Okay. Then I would do the distance formula for that segment. And I would do the same thing for D and C. So if this is 4, 5, 6, 7, so 7, 1. And then 8, 9, 1, 2, 3, 4. 9, 4. Then I can do the distance formula there. So the segments, you have a bit more that you can work with, and you can actually get proof rather than just kind of estimating, you know, yeah, I think that looks fine. if I did the estimating or the guesstimating way, this is 1, 2, 3, 4. Segment EF is too long. It cuts through 4 while the other two are about 3. Okay, so we see the S. We see there's no actual math here. It's just kind of like, yeah, that looks about right. And I have to clear everything because.
But C looks smaller than A in the first one.
It does. And in the angles, right?
Yeah, I'm not talking about the arrows. I'm talking about the
Yeah,
angles.
you know what it is that I keep trying to zoom in on my iPad, but I need to zoom in on the computer. The thing is that they shrink the sides, the lengths of the sides. If I were to continue, right, to get it to about the same, they're not going to be the same because they're slid over. But if I were to do it to the same length, now they look the same, right?
Wow, that's crazy.
The key to remember is that when it comes to angles, you're looking at the measurement of the angles and not the sides. Because your sides, you can do whatever you want. You can make them smaller, you can make them bigger, but the main thing is that the angle itself is the exact same. I hate that I can't use any of the colors. I guess I'll just do red, forget it. The angles are the same length. Doesn't matter the length of the sides, what matters is the size of the angle, okay? Any questions on this? That's the last part of this section. So
Can we do the distance formula for the lines?
What were my points that I made?
You put 2, 4, and then 4, 1 for
Why you don't believe me, Kaylee?
And then 7, 1, and then 4.
All right. So we're doing our distance formula for the first one. So 2, 4, 4, 1. I should make Matt do them. Isn't he our expert distance formula person? Gabe says yes. So you have x1, y1, x2, y2. All right. What is it? 4. Okay, you got to do it with me if you're making me do this.
Wait, hold on. Okay, here we go. No, don't you put x2 first? Oh, sorry, x2 is 4.
That is x2.
I'm so funny. Haha. Anyways, so then 4 minus 2, then parentheses close, and then the exponent, plus parentheses open 1 minus 4 parentheses close, and then the exponent. Yep.
Squared.
Yep.
All right. So now I can go ahead. 4 minus 2 is just 2 squared plus 1 minus 4 is going to give me -3. I'm going to kind of go through this quickly because I want to make sure that we finish all the lessons for your test. 2 squared is 4 plus 9 gives me what? Square root of 13. Okay, so that's my magical number. That's the number that I'm hoping to get when I do segment CD, which I'm going to do in a different color on the other side of the page. So we're going to do what? 9, 4, 7, 1, x1, y1, x2, y2.
I think Matthew should do this one.
I think Kaylee should do this one. She's making us do it.
I don't know. I think Gabe volunteered Matthew, so.
Let's see. I should have made Matthew do this one while I did the first one. That's what I should have done. It saved us some time. -4 squared. So that ends me with that's a 2. Somewhere in the world that's a 2. Negative plus negative 3 squared. Did I get the same answer?
Yeah, you did. That's so wild. Wow. Okay.
It's crazy, right?
Thank you.
So that's what you would do if you wanted to be 100% certain. Like, let's say you do your guesstimating with the segments, but you're like, I'm not 100% sure. Make up the point. Obviously, don't just make up the points. I mean, you could technically, but I would recommend starting with this being your 0, 0, and then working from there. Okay. We're good with this now?
Yep.
You all understand? Okay, perfect. So now we can move on to the next section. Corresponding parts of congruent figures are congruent. It's like a tongue twister, right? All right, I'm going to switch because now we can actually have notes. So I have to share this screen. And switch over to my geometry part. There we go. See, I thought ahead. I wrote the notes. To save myself time, I'm not rewriting them. We're just going to go through it together, but these are the same notes that second period got. They're the same notes you guys would have gotten. Look at my beautiful triangles. They look pretty congruent, okay?
Alexa
This is how.
complimented them.
What?
Alexa complimented them.
This is what I need.
Very symmetrical. They look very nice.
Yes.
They need to get rid of that whiteboard and just give me a giant iPad with this app on it, and we're good. I think that's doable, 100%. I'm gonna write to Apple, tell them to make me a giant iPad. So the first thing that we need to talk about are corresponding parts of congruent figures are congruent, okay? It kind of says it all in that whole giant blurb, but it's saying, basically, if I have two shapes that are the exact same size, all the parts are going to be the same. All the sides that match up are going to be the same size. The angles that match up are going to be the same size, and so on and so forth. So if two figures are congruent, that's the key. They have to be congruent. And they'll usually tell you these shapes are congruent. So if two figures are congruent, then corresponding sides are congruent and corresponding angles are congruent. Basically just saying all the parts of this shape are going to be the same with the corresponding parts of the other shape, okay? Which we can see here in my first little triangles. We have triangle ABC and triangle DEF. Now they are congruent. See, it says right there, triangle ABC is congruent to triangle DEF. So angle A matches angle D. So if angle A is 45 degrees, angle D is going to be 45 degrees. Okay. The same thing if angle C is 75 degrees and angle F is the one that matches, angle F is also 75 degrees. And E is 60 degrees, so the matching angle B is 60 degrees as well. Okay. Yes, we see it? And the same thing for the sides. So side AB is the same as side DE, so it's 2.5. AC is the same as DF, so it is 3 inches. And BC is the same as EF, which is 2.9. So it's just pretty much looking at your shape and figuring out which side matches with which, and that's your answer. It's pretty simple, right? So then we have 3 important properties to help us when we do proofs, right? Our favorite, we love proofs. These are the ones that are going to help us. There's the reflexive property of congruence, which says that the segment AB is congruent to segment BA. So that basically is the same angle or the same segment, just swapping your letters, but it's matter. It's like going from right to left to right. Like a palindrome. You don't know what a palindrome is? Do we know what a palindrome is? Palindrome is a word that when you spell it, no matter which way you spell it, it's the same. Okay, and this is really bad because it's the only example I can think of right now. Taco cat.
Race car. Anyway.
Race car is another one. That's
Wait,
much better than taco cat.
Oh wait. Wait. Oh, never mind.
If I spell taco cat backwards, I still get taco cat. If I spell race car backwards, I still get race car. Race car is a much better example, and I wish I didn't only think of taco cat. But that's the point. It's the same both ways. That's kind of what the reflexive property is saying. It doesn't matter which way you write it, it's going to be the exact same thing. So it's basically a palindrome. Okay, then you have the symmetric property of congruence, which says that if AB is congruent to CD, then CD is congruent to AB. So it's similar to the reflexive, only instead of changing just the letters, you're actually changing the whole segment, the order in which the segments are given, right? Point is that it doesn't matter because both of them are congruent. So they're both congruent to each other, so I can write it whichever order I want, okay? And the last one is the transitive property. So the transitive property is a little bit funny, okay? If AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. So basically you're transferring the property of the fact that AB and CD are the same, and you're applying it to the other one so that you can say that AB and EF are also the same. Does that make sense? Yes, we understand the transitive property?
Yeah.
Okay, so it's pretty much just transferring. So we have an example here. Now there's more to this example, but I didn't really do it all. I'm going to erase it so that we can do it together. But I have to be careful not to erase my lines. So I have my two triangles, and I have a missing angle here and here, and I have a missing side here and here. So what I'm going to do,
We can't see it.
you can't see it?
Yeah.
Like it's too light, or you can't see my screen at all?
No, because like I think where you're drawing is more at the bottom, and like Zoom only is taking up the top part, if that makes sense.
Am I scrolling? Am I doing anything?
Wait,
Because on my screen, because remember I have Zoom on two different devices. So when I'm looking at my computer, I can see my whole screen.
wait, but don't scroll because we need to finish the notes.
Oh, okay. I'll
Yeah.
wait then.
Thank
And then if it doesn't work, but where is it that you're getting cut off?
Like it just has it has all the notes, transitive property of congruence, whatever the example, and then it has a little bit of space, and then we could see the end of the line of the first line of the two lines, and then it just kind of comes out.
So where are we not seeing?
We're not seeing what you were just drawing.
You can't see my triangles at the end?
No, what you were just drawing.
Can you see if I draw here?
Oh yeah.
Because I just circled this.
Oh, I couldn't see that.
Maybe it was too light.
It was hidden. Okay, thank you. Sorry.
So I'll wait a little bit so that since we're still copying the notes. But this part is easy. Your homework is easy too. Do you guys owe me homework today? Oh my gosh, Matt, I saw that. I saw that look of panic that you gave Gabe when Gabe was saying yes. So I have not officially decided how you're going to show homework to me. for right now, just send a picture to remind, and I will see it. I think I'm gonna do the Dropbox, but I don't want to do the Dropbox without having, basically next class, I'll show you how the Dropbox set up, and then we'll go through how you submit the homework through the Dropbox, okay?
Miss Perdomo?
Yes,
You
Kaylee.
know how like, okay, so you know how like the example for the first problem goes down to like the third key term? Is the second example an example of the transitive property?
No.
Wait, so what's that example for?
So this example is kind of for the other properties. We're going to see an example of the transitive after this example.
But which example does that go with?
This one kind of works with the symmetric
Okay.
property. Okay.
Okay, thank you.
So the point is that we're saying AB is congruent to DE, right? So if they're congruent, it means that these sides are the same. So I can write 3x plus 8 equals 5x. Can you guys see that? Okay, I'm actually going to rewrite it over here because I realized I wrote it probably too big. And I need to make sure I have space for my other problem, which is with the angles. So if my angles are the same, A and D are supposed to be the same angle. That means that 5y plus 11 equals 6y plus 2. Okay, so all I'm doing is I'm looking at the symmetric property and saying that these two are the same. I'm using my corresponding parts of congruent figures are congruent so that I can set the equations equal to each other. And now I just solve for x and y. Okay, so my first one, I'm going to go ahead and move the 3x to the 5x. Remember, I kind of want to stay in the positives. So I'm going to move the 3x so that my 5 can stay positive, which leaves me with 8 equals 5 minus 3 is just 2x. Divide by 2. And x equals what? Eight divided by 2, guys. 4.
Yeah.
4. Thank
But
you.
Wait, but what are you doing? I was copying the notes and then all of a sudden there's a 4. Like,
Yes.
but
Where were we not paying attention?
because I was copying the notes, so I was pretty concerned about that. I'm sorry.
Okay, did we see where I got this equation?
No.
So my triangle over here says that this line, this segment is 3x plus 8.
Uh-huh.
And this segment is 5x. Now they're the same side, right?
Mm-hmm.
Meaning they're equal to each other. So I just write 3x plus 8 equals 5x.
But how do you know they're equal to each other?
Because they're congruent.
Oh, so okay.
I didn't write it, but yes, they would say they're congruent.
Okay, so then that's like solving for the x, right?
Yeah, so then you just solve for x.
What do you do about the y's at the bottom?
Same thing.
Oh.
It's the same thing, right? Only now it's a little bit more annoying because 5x was much easier to work with. So now I have to move a bunch of stuff over. But remember, I want to keep it the same rules. I want to keep positives. I want to avoid negatives at all costs. So for that, I'm going to move my 5y first. I need to change colors. So 6 minus 5 is just 1. So I can just leave it at just y. I don't need to write 1y. It's kind of silly. Plus 2. Okay. Now I move my 2 over. And y equals what? Come on, guys.
9.
Yes. 9. So I'm going to stop this problem here, but what you would do afterwards is you would plug in your X and your Y value to figure out what that angle is. So like, for example, let's say I want to figure out the length of my sides. I only need to use one equation, so I'm going to use 5x because that's easier for me. 5 times 4 is equal to 20. I can check, but this side is also going to equal 20. Both sides are equal to each other. So if one is 20, the other is 20. And the same thing for the angles. You don't have to copy this part of me working through. I just want you guys to see that if I were to do 5 times 9 plus 11, that gives me 45 plus 11, which is 56. Yes? So my main point was to show you guys that these two are equal. You can solve for X, plug it in, and that's it. Are we good? No, I saw.
Wait. Wait, I'm not done copying the notes. I'm sorry.
Okay, you guys can keep copying the notes because then we have to switch over to the book again for the last section, and that's it. Are we good? Kayla's saying no still. Kaylee, did we finish copying the notes?
Sure. Yes.
Yes? Listen, what I'll do is finish the notes and then I'll come back to this. So
No,
if you
I
didn't
finished.
you finished? Did everyone
Yeah.
else finish? No one else talks to me, so I don't really know.
Because I'm the one with the sound. I'm special like that.
But everyone else in the class, I know Elena said she was done.
Good job.
Okay, I'm gonna move on.
Yes, we're done.
Okay, perfect. So now I have to go back to my other screen. And I don't know why I closed this because I need the annotation. Okay, there we go. So I'm here. We already went over all this. So you can see this also, I just want to go over this one. We're not going to do the question itself. I just want you to see these shapes are not in the same orientation. You're not going to find that often. Most of the time, they're not going to give you the same shapes right next to each other like I did in mine. Actually, this is the example that I used that we just did, that I did the first problem I did of finding the angles and everything when they were the same shape. They weren't facing the same way. I made my life simple and made them face the same way, but most of the time they're not. They're going to be whatever way they want to give you. See, like this funky thing. These are the ones that we just did, the 3x plus 8 and the 5x and the 6y and all that stuff, you can see 20 inches, 56 degrees. So we did the correct work. All right. Now, this is the part to talk about. Using congruent corresponding parts in a proof. So we have here, given that triangle ABD, so this triangle right here, there we go, and triangle ACD are congruent. So they're telling me these two triangles are the same. Prove that D is the midpoint. So my goal is to say D is the one in the middle. So first thing, and this is how it usually is, they always start with the given information. So triangle ABD and ACD are congruent. That's given to me. So this kind of looks like what you'd had on the diagnostic test, right? It was this kind of square, and then you had to drag in the proofs and all that stuff. So this is what it looks like. This is completed going through the examples in the book. So like I said, a lot of the stuff on that diagnostic you probably hadn't seen before because it's for everything we're learning this year, all right? So then it says segment BD and segment CD are congruent because corresponding parts are congruent. So that's looking at these two sections, B to D and C to D, right? They're both the base of the triangle, so therefore they would be congruent, right? Now, D is the midpoint of BC. That's the definition. The definition of a midpoint is the point that lies in the middle and gives you two equal halves. That's what we already said, these two are congruent. So that's your proof. Your proof is basically this works because this is true, and then because that's true, this other thing is true. Does this one make sense? You got this one? Okay. So the next one is where it gets a little funky, right? So I have to clear, well, I didn't even clear everything. I don't know. This is gonna bother me. I don't know why I won't clear that part. All right, moving on. So we now have quadrilateral JKLM. This whole quadrilateral is congruent to quadrilateral NPQR. And angle J is congruent to angle K. Okay. This one, what I was telling second period, it's a little weird because they're not in the same orientation. So the best advice I can give you is to kind of make them so, right? Obviously you can't reach into the screen and flip it, whatever. So just draw, and bear with me. This is freehand. I don't have my fancy tools now. My goal is to make it kind of look like the other one. It's not perfect, but it works. So L slopes down, M is the higher point, J, K. Okay, that makes it a little bit easier for me to see. All right. So now, again, we start with the given. What, Kaylee?
I'm sorry, but how come you flipped J and not R? I mean, JKLM and not RQPN.
Could I have flipped the other one?
I mean, yeah, but like,
Yeah, doesn't matter. I flipped the JKLM because I like that flatter bottom to be my bottom rather than the top. This length, this side here, I prefer that to be the bottom of my shape than the top. I could have flipped it either way. My point is that I get it so that they look the same, that they're the same orientation and everything.
Yeah.
Okay. I could have done both of them sideways if I wanted to. Point is that they're the same. Okay. So again, quadrilateral, JK, LM, and the other quadrilateral are congruent. That's given to me. Now I know J and K are congruent because that's also given to me. Now, angle K is congruent to angle P. Is that one true? Is this one in the same spot as that one?
Yes.
Yes. So because they're in the same spot, that makes them corresponding parts. Corresponding parts of congruent figures are congruent. So K and P are congruent because they're the same. They line up in the same spot. This is why having the shapes be in the same orientation is so important. For example, in second period, when I started it for a second, I thought that J would line up with P, but it doesn't, right? If I rotated the shape, I still would have had to reflect it because it wasn't in the right way. I was thinking just rotating it, oh yeah, I would have gotten the same, but it wasn't, okay? That's why I said just draw it the correct way because it makes it easier to see, all right? Now, we're looking for the transitive property of congruence. There it is, that then says angle J is congruent to angle P because angle J is congruent to K. I'm going to write it exactly as the definition gave us. So if angle J is congruent to angle K and angle K is congruent to angle P, then angle J is congruent to angle P. We see that? That's how the transitive property works. If J is the same as K, K is the same as this other one, then my first one and my last one should also be the same. That's your proof for your what they want. So whenever they do the proof, they tell you, we want this, and it's going to be true. I'll give you a heads up. It's going to be true. They want you to prove that it's true. All right. Any questions on that? Because that's the last example. Your homework is page online. I don't know what the in-person is. So online, it is page 128 and 129. Problems 2 through 7 and problem 14. That is the homework. Any questions for me?
Yeah, so we don't turn in the work until you send the Dropbox?
No, send in the work that's due today through Remind.
Okay, and then
And
when is due?
This one will be due on Wednesday. This is your last homework for this topic test, okay? So if you missed any homework, now is the time to go back and review, because what happens when we do topic tests, I check your notes and I check your homework. So if, for example, you were missing homework from before, on your test day, I check it through. You have everything, maybe you don't get the full A because it wasn't done on time, which is why I checked for completion every day or every other day. And then after that, I can check it and you can get a B instead of maybe like a C or a D if you were missing a bunch of homework, okay? So with that, we are done for the day.